Greetings and welcome, internet friends. Me and my G-amigos have been proving triangles congruent using side, side, side and hypotenuse leg. The one time in which angle dollar sign is a legitimate theorem. Actually, hey, internet friends, let me show you my cool geometric sketch. Oh, look at that. There are two possible triangles formed by angle side, side, this blue one and this red one. So you'd be like 50% chance as far as determining congruence. But the one time they are always the same is when they're oh so right. Come on. It's oh so right. You right that? Right, guys? Right, cool. All right. So I do, oh, by the way, I say all right or right a lot. I don't know why. So, question 4. Could I prove by the side congruence theorem? Looks like I've got, oh, that's funny. I'm drawing behind this again. Oh, man. All right, here we go. Now I'm drawing right. So I've got one pair of sides. So that's an S. What else do I know? QS is congruent to itself. That's another pair of sides, right, my friends? Why is QS congruent to itself? Reflexive. You guys are so good at spotting that. That's one of the top 5 frequently used reasons in Wadi math. Now the question is PS congruent to SR? Thoughts? Yeah, I'm hearing yes. Why? I mean, we want them to be. I was never told that it was. So I think the answer to this question is no, because all I had was side, side. Yeah, that's a tricky one. All right, let's take a look at question 9. Decide whether the weather be hot or whether the weather be cold, we'll be together whatever the weather, whether we like it or not. I had to practice that in speech class in college. Decide whether the congruent statement is true. Explain your reasoning. Oh, you guys spot this. FD is congruent to itself, reflexive. Those triangles are congruent by the side. That time I do have 3 sides, right? Right. All of the angles go berserk. So, check it. Redraw the triangles so they are side by side, not side. So, sometimes it's good to, I've got like a weird off-green moss, which, by the way, moss happens to be Captain Wilderness's trail name. Ooh, there you go. I consider moss to be the chrome of nature, where it just makes everything cool. So anyways... No, I'm getting some head nose. You can't call that a nod. That's a shake, I guess. All right. An unnod. So, all right. I've got some gimme information on this. I'm going to label it both up here and on these. AC is congruent to the DB. That's nice. That's helpful information for me, right? So this whole one and that whole one are congruent. I also have been told there's some perpendicularity right here, Larry. Larry the lobster, all right, guys? So based on those perpendicularity, I'm going to eventually try to say that these... Oh, right there. Okay, they are right angles. I already used that. Okay, so this actually has already been done. But def of perp tells me that those angles are right angles. So I can't use that as my row 2 statement. The fact that these are right, what route do you think we are going to prove this? Probably HL, right? The moment you see right triangles, start thinking or aiming for that HL, okay? So let's see. So right now, I've got an H right there. So here's my H's. Looks like I've got some H. I need a leg. So I need to either show that AB and CD are congruent, or show that AD and AD are congruent. Thoughts? I bet AD is congruent to AD. What's a cool AD acronym out there? Advertisement. And why are those congruent? Reflexive. Reflexive. One of the top 5 frequently used reasons in Watty math. Man, that's the most annoying thing I've ever done in my life. All right, so that would prove this congruent to that, right? It's easier to see on this sketch where they're definitely the same, but the fact that they have the same name would suggest that they are the same to begin with. And what about this right here? How could I show that those triangles are the right triangles? If those are right angles, then these triangles are right triangles by the def of what? Def of right triangle. I'll just draw a little triangle there. Oh, also, I forgot to mention, I've got my other leg right there, right? HL, HL, LL, LL. So hypotenuse leg triangle bad is congruent to triangle kada, kada. Yeah. All right, so that's right there is a nice little fill-in proof for you. Now, technically, this row could have shown up down here. Like, the order of the proof sometimes has a degree of flexibility to it. So don't always think it's got to be locked in like that. Let's take a look at 14. All right, whoa, lots of gimme information. Oh, G is a midpoint. That's nice. GF and GI are congruent, or FG, whichever, right? Yep. Oh, the hole punch cut out the 14. Mystery question. Wow. So right here, I've got a midpoint. Oh, I also was told, that's nice. They told me those were right angles. So that doesn't just mean perpendicularity. Those are actually right. Oh, and if those are right angles, it looks like I ended up saying that those are right triangles by def of a right triangle. Nice. Okay, so it looks like I'm aiming for hypotenuse leg. Right now, which do I have? Do I have a hypotenuse or a leg for congruence? These are hypotenuses, right? And I know that because the hypotenuse is always opposite that right angle. Yeah, that's a nice little fact there for you. Hold on to that one. So I've got the H's. I'm looking for some legs. Which legs are can I show congruent? Simultaneously. GH and EG are congruent? There's a few different ways you could have named them. So G, E, and GH. And why are those congruent? Yes, it's this midpoint fact that's helping me out. So def of MP right there. And so now there's going to be the legs for my HL. Looks like I'm good to prove these triangles congruent. And the names of those triangles, we can literally just yoink. By the way, yoink is the official sound effect of stealing. There you go. Yoink. Yep. Also, if you ever walk into a convenience store and not steal anything, but say the word yoink, they'll think you stole something. True. I agree. Mr. Watty does not promote stealing, but feel free to use any of my audio samples from these YouTube videos for ringtones to sell on phones in 1998. They used to sell ringtones. Isn't that crazy? People used to pay money for ringtones. Wow. All right. Actually, true story, I once recorded a Gears of War sound effect and used that as my ringtone. What? Crazy. Gears of War reference. All right, so check this. I've got a whole bunch of gimme information. Good, I believe it. This one looks scary, guys. Why are these congruent? WV. Oh wait. Oh, yeah, good spot on that. I'm gonna quadruple mark that. That's congruent to itself by reflexive. All right, you guys be writing this down. This stuff is gold. All right. Now this one, I don't know if you guys will spot this. It's pulling from here. how could I switch from the world of congruence to the world of equality? A man in the front, J Money, is saying Def of Kong. And he is correct. One of the top 5 frequently used reasons in Owati math. All right, J Money, yeah. So Def of Kong, and this is going to help us out. I have a feeling the fact that I'm switching to the world of equality usually means some substitution or transitivity is going to happen. All right, now this one's tricky. I gave you guys a heads up on this yesterday. Why are those things true? No. No. Now let's look at the picture. WZ is equal to WY plus YZ. What is that an example of? The big segment is equal to the 2 little ones added together. Segment addition postulate. Good old SAP. Seg post. Right? Right? So, all right, here we go. I have a feeling that this is going to be subs. I'm going to write that. Let's see if we can see what subs happened. So this is a VX. This is a VX, so that's a match. This is a WY. Is there a way I could have substituted a WY in for a VY? Yeah, right there. So I think that got subbed in there. And then YX becomes YZ. YX could have been subbed in right there. And that became YZ. So this is actually a double subble. What? Man, remember Carmen Sandiego? No, nobody? Someone's gonna get that reference in the comments. Double Trouble was a bad guy in the Carmen Sandiego TV series. Where in the world is Carmen Sandiego? Anyways, all right. So I done did some dub subs. Now I've got transitivity happening here. I think it's going to be these two equaling each other. Let's see if we can follow the transitive train. Vx is equal to this. And that is equal to Wz. So I think I'm going to write Vx equals Wz. Now, the reason that's even helpful is I'm trying to go to show that this whole length and that whole length are congruent to each other. So if I could show that those sides are congruent, right, I'll be closer to proving triangle congruence. So I think that's the case. And also, since this is a fill-in-the-blank proof, notice this next line. If that is going to happen using def of Kong, then the line above it probably had to be similar to it, but in the world of equality. So that's the two ways I could kind of have cheated that. All right, so I just showed that this entire segment and this entire segment is congruent. Now, I had a student just suggest, is this HL? Now, those do look like right triangles, but I don't know that. So how could I prove? I think we got side, side, side. Right? I happen to have these, right? I happen to have this, right? That's another S. And then I happen to show that those looking like hypotenuse segments were also congruent. So I have three sides. Actually, let me draw one of these triangles. Disconnected from the other one. Right, I happen to know all three sides were congruent for each of those triangles. It's a little bit tricky when they overlap, but it's not a bad idea to separate those sometimes. Let's see, I think that's all the problems I picked for today. But yeah, you might have separated them like that. So side, side, side. Side, side, side. Well, thanks for watching. Have a great day. Adios.